I mentioned, like what we will cover. This is the overview. Maybe I'll make it full screen. Got it, right? So we'll talk about what is data science, why data science, components of data science landscape, the process, right skill sets, ideal data science team, the activities, the development life cycle, some use cases and challenges involved. Now, what is data science? Basically, I define data science like data science is an interdisciplinary field of scientific methods. And what are those scientific methods? I'll talk about it. Processes, algorithms, and systems to extract knowledge or insights from data in various forms. Okay, either it could be structured or it could be unstructured. Sometimes, why I mention this structured or unstructured is many a times you may get data in terms of some structure, like the tabular structure, and many times you may not get data in a structured manner, like say some of the questionnaires or some of the survey forms, etc. You all know about Google Forms. Just to give a real life example, Google Form, there could be some form for Amazon, for Azure, etc. And those are unstructured. I mean, those forms have some data, and then from the those unstructured data you need to put in a structure, right? You need to put in a tabular format, and that becomes structured then. So we can analyze both structured data as well as unstructured data. So it's basically a interdisciplinary field of scientific methods, processes, algorithms, and systems, so that we can extract knowledge or insights from structured data or unstructured data. And it's a combination of like statistical science, mathematics, information science, and computer science. So if I say in one sentence, this is my language, like data science is an advanced application of statistical science to extract meaningful information and insights from data. Right? So hope you got it. Uh, I see some chat. Okay. Now, so that's what is data science. And why data science? This is important because why do you need to learn data science? Or why do we need data science in our daily life? You know, just to start with a very basic example, you may laugh, but think about like your mother or I mean your parents cooking rice for you. You know, like what we do while cooking rice. I mean, at the time of boiling, right? We test some samples, right? Like say one or two rice, and then we check whether it is done or not, right? I mean, it's cooked fully, I mean, cooked well or not, right? That's called sampling. That's where statistics is used in day-to-day life. There are many more examples, right? Like in cricket, in football, in sports, in utility industry, in insurance, in banking, in retail, CPG. Those are industry specific, but in our daily life also we use statistics, like I mentioned, right? Okay, so first of all, we use data science for meaningful information extraction, as I explained to you. So, and second thing is to automate a continuous process. Suppose you have a problem statement in hand, and that could be a valid data science or machine learning use case. And so far, you were doing it manually. I mean, you have a process in your department, and that process was being followed manually. All the activities so far you have done were manual, right? Now you can automate that using data science or machine learning if that is a valid use case. Again, I'm repeating. So why I'm repeating that if valid use case? Because as you might be knowing, like entire world is chasing after machine learning, right? So you need to be cautious that everybody is claiming that all the projects are data science projects. That's not true. That's not true because machine learning is not, I mean, it's not like all projects are of machine learning projects. Some of the projects are IT, and it is forcefully, I mean, we are using machine learning. That's why we are calling it as ML project. No, this is not ML project. So by valid ML project, I mean it really needs to be a data science project or machine learning project. I'll explain you how to detect like whether it is an ML project or not. So slowly, at the end of the course or at the middle of the course, you'll understand that. Now, to reduce human effort, obviously, if we automate a continuous process, we will reduce the human effort, right? And then to save cost, because suppose think about it, like if some process were being executed manually and you had a lot of resources. Now, once you automate the process using machine learning, certainly it's going to save cost. I mean, you can you can utilize your resources in other activities. I'm not talking about, say, we do not need resources if we automate using data science. No, it's not like that. Even if we automate using data science, still resources will be required because data science is not about only automation. It has many things. I'll talk about one by one during my next few classes or sessions, right? And for better prediction, you can understand like when you are applying say some of the excel formulas or some of the logics for your data for a vast data, that time what will happen is um, that could be based on your experience, right? But it may not be correct, it may not be accurate. Some of the formula like you have put for regression y equal to mx plus c plus e etc, right? That may not work provided you are studying it properly and you are solving using a data science algorithm which is fit for that particular problem statement. So that's why uh, it is used for better prediction and for higher efficiency. So why higher efficiency? Because if you automate a process, you do not need so many resources, you do not need so much infrastructure. So obviously the efficiency gain will be there, right? And there will be return in investment for a particular business set, business problem. Obviously, this will also enhance your decision making power. How? Because using it machine learning, you can enhance your decision making power. Like you'll be in a better position. Let me give you an example. Suppose you have a bank or financial institute and you are giving loan to the candidates, and you want to detect like which people, what are which of the people like may fault, I mean may default, right? So certainly, you do not want to give loan to those defaulters, right? So that's the enhancing decision-making power you are coming up using machine learning problem, which is a classification problem, right? And obviously, once we do all these things, we are going to make our life easier, right? So these are numerous advantages of choosing data science or adapting data science or learning data science and applying data science, right? Now, say, what are the different components of data science? So, data science has primarily different components like, say, statistics, visualization, machine learning, and domain and business. These all four are important. So, what is statistics? Statistics is the like again a subject like scientific science subject, which is a collection. I mean, collection, tabulation, analysis, collection, tabulation, presentation, analysis, reporting, and presentation. Okay. So, in statistics, what we do, we collect data, we tabulate data, we analyze data, we generate some reports from the data, and then we present to the stakeholder or present to the parties, different parties, or present to our clients, etc. Right? And what is visualization? Visualization is the like visual access to huge amounts of data in easily digestible plots or graphs. So through visualization, we understand a lot of patterns. Suppose you have a huge data set and you may not be able to visualize that data set right at a go. So what we need to do is we need to come up with visualization, a lot of suitable graphs and plots, and the plots depict the true picture from the data. Like it talks about some pattern in a specific variable. It talks about relationship between different variables, and it depicts like whether it's a linear relationship, non-linear relationship, etc. And what is machine learning? Machine learning, like it explores the study and construction of algorithms, like that can learn from and make predictions on data. So what is machine learning? We are teaching the machine to learn from data. Okay, so we are giving input as data, and we are using a algorithm, right? We are pre-processing the data, we are using some algorithms, and we are telling machine that okay, learn by this approach, because for this problem statement this is the most suitable solution, so learn accordingly, right? So we are teaching the machine, and machine learns on its own, depending on our entire automation process, right? And what is deep learning? Deep learning is advanced version of machine learning, right? In deep learning, what we do, we try to convert the machines like a human brain works, like artificial neural networks. So we teach machine, and we teach machine so intelligently that it becomes as intelligent as human brain, right? That's what deep learning is about. And what is domain and business? Why domain and business is required? Trust me, domain and business is very, very important to solve any data science problem, because data science is not only about algorithm. Data science is also about understanding the domain or business, understanding the challenges that the customer is facing, and then creating a valid problem statement, right? And then solving that problem statement. That's why without domain knowledge and business knowledge, machine learning projects will certainly fail. Okay, or there is a high chance of failure because what will happen without understanding the domain, we may come up with wrong problem statements and solve it, right? And that's not going to give the advantage or say the necessary ROI to the business. So if my data science project or machine learning project is not going to give the efficiency gain or is not going to give a good ROI, then obviously it's not successful, right? Okay, so now, what is the different landscape? Like we talk about, we have data analytics. In data analytics, we do feature engineering. So don't get afraid by these terminologies. I know if you have joined newly and studying from scratch, so don't worry. I'll I'll cover some of the logic, foundation, algorithm, background, and scripting also Python scripting. So data analytics, we do feature engineering. So basically, feature engineering is nothing but for your in a simple language, it's like creating some new variables or deriving some new variables. That's called feature engineering. So like when I was studying MSc, I mentioned that I used to solve problems, right? That time also we were using, but we were this feature engineering term, this feature engineering, feature selection term, these are just terms that came like few years back or few decades back, but these were there for many decades. Okay. uh, so feature engineering is nothing but deriving some of the new variables or creating some new variables. And data wrangling, like you wrangle the data, right? Then you do exploratory data analysis. Okay, that's what all about data analysis. And programming, like we have several program languages like R, Python, SAS, SPSS, MATLAB, Minitab, etc. But we'll prefer Python. The Python is the best language, most generic language. You can develop games, you can create websites, you can create applications, you can create machine learning models, you can create text mining algorithms, you can create deep learning algorithms, and many more. Right? So, and Python is scalable, highly scalable. You can make it scalable, and Python is much easier compared to these languages. Python is very easy. Okay, if you know English, you can learn Python. That's the say from one of the scientists, right? So, and what is the machine learning? Machine learning like talks about different aspects. Like it talks about classification. What is classification? Like I mentioned, whether a person will default or not. That's a classification problem. What is regression? Regression is like whether you are predicting the market price, say some of the stocks, etc. Like that is called regression. What is clustering? Clustering is nothing but you want to segment, get some clusters of your customers. Suppose you have your own telecom institute. Right? You are a telecom service provider, and so you have a lot of customers. So you want to understand how your customers behave, different customer segments, whether it is a high-end customer, medium-end customer, or low-end customer. Whether some customers are going to, what's their behavior, etc. So to understand that, you apply clustering. Okay. What is reinforcement learning? Reinforcement learning is like learning from experience. Like you are applying an algorithm. If it fails, then you are again retraining based on those failure conditions. Like why did it fail? You are going to explore, and then you are going to fine tune accordingly. You are going to teach the machine more intelligently, right? And what is deep learning? Deep learning I mentioned, right? Deep learning is to make the computer or machine learn like a human brain. Okay, it has many algorithms like ANN, CNN, LSTM. ANN, CNN, RNN, LSTM, etc. And we have data visualization also. So data visualization tools are like Tableau, Power BI. Okay, R has also good packages like ggplot and ggplot2. Python has good packages like matplotlib and seaborn, etc. Right? And there are many IDEs to write these program languages. IDEs, integrated development environment, like PyCharm, Jupyter, Spider. These are for Python. RStudio is for R, right? And there are many more. And if we talk about cloud, or say deployment, where do you deploy the things? Like we have Amazon Web Services, we have Azure, we have Google Cloud Practice, right? And many more like Alibaba Cloud. Okay. And there are some of the web scraping also. What is web scraping? Web scraping is nothing but extracting information from websites or URLs. directly, right? The contents like HTML contents or XML content, whatever, PHP content. So like there are several libraries in Python like Beautiful Soup, Scrappy, URL etc. And obviously mathematics is needed like algebra, calculus, and probability, basic understanding, and some of the calculations, right? So I thought to cover one good landscape of machine learning or data science. Now, now it's a good part, good important aspect like what is the data science process and how does it work? So remember that I used to repeat, I am repeating that domain knowledge, business understanding is important because that's where we starts data science. Okay. So what we need to do, suppose you are working in a company and say you have several business units or service units or say multiple departments and who are reaching to you like, okay, hello, XYZ, whatever, can you solve my problem? So what do you do? Firstly is you schedule a kickoff meeting, right? And in the kickoff meeting, you understand like what are the challenges they are trying to face. And also you try to assess, okay, what are the possible opportunities also for adopting AI and machine learning in this particular for this particular department, right? So that's why you understand the business initially through some kickoff meetings or in-person meetings, right? 3 to 4 meetings, or depending on the complexity of the project, you may need some more, but you understand their business. Then once you understand their business, you can frame some analytical approach. Okay, just in your mind or in some like pen and paper, draft analytical approach, and that approach like we'll think about like say data requirements like for a specific problem statement like say loan defaulters prediction or say product subscription or say clustering, or it could be any algorithm, it could be any aspect like it could be classification problem, it could be regression problem, it could be reinforcement learning problem, it could be clustering problem, etc. So you want to know like what are the data requirements. I mean, what are your data requirements? That's very important because unless until you define the data requirements, you cannot proceed. Then once you chalk out the data requirements, you collect the data. So this data collection is important because if you choose wrong data, entire machine learning model will fail. So choosing data wisely and choosing data correctly with good quality is very, very, very important. Okay. Now, once you gather the data requirements, once you collect the data, then you need to understand the data, like what it talks about, like what are the different variables, how they're interconnected, uh, what patterns they have, etc. Right? And then based on those things, you prepare data for modeling. So before modeling, you prepare the final data, and final data preparation will again take a lot of activities. I'll mention about those. So once you prepare the final data for analysis, you apply modeling. Okay. So once you apply modeling, this modeling piece is only machine learning. Okay. See, data science is a bigger superset, right? So machine learning is a subset of data science. Data science is the entire process, and machine learning is mostly like modeling, evaluation, fine tuning, etc. So from modeling, once you develop a model, you evaluate the model. So why modeling is important? Because suppose you are solving a classification problem, and classification problem has several algorithms. Okay, 20 to 30 even more algorithms. So you are going to compare some of the models, and then certainly you need to evaluate like which model is working better, right? Okay, which model is working better. So once you know like this model is working better, and you test his, you check his consistency, accuracy, precision, recall. I'll talk about all those things. Uh, and once you're confident that okay, my model is giving the better results or the better prediction, then I can deploy. So you deploy either in your local server, I mean in your company server, or some cloud server, Azure, AWS, with GCP, right, and so on. And then once you deploy, you collect feedback from the end users. So these are your end user department, and this department has a lot of users who is going to use your application, right? So you collect feedback from them. Okay, like how the application that you develop, machine learning application or product that you developed is working. I mean, is it going to work? Is it working as expected, or is there any some is there some issues like which can be fine tuned or which can be relooked, etc. Right? So once you so this is called also called feedback mechanism. So once you come with the feedbacks, you again fine tune the models. I mean, there may be a need of fine tuning the models. Right? That's how the entire process. Wherever there are double-sided arrow, that means from data collection again you may understand data requirements. From data understanding again you may go back to data collection, etc. From modeling again you need to go back. I mean, you may go back to data preparation in case some of the variables are needed. Right. From evaluation again you can go back to modeling, and from feedback mechanism go back to model. Right, based on the feedback from the end users. That's how you make it more and more and more intelligent in the coming days. So this is called CRISP DIM approach, cross industry process for data mining approach. This process is called CRISP DM, cross industry process for data mining. Now, in terms of data mining, there is another approach, KDD approach, knowledge discovery in databases. KDD means knowledge discovery in databases. So this is simpler compared to the CRISP DM approach. So some data from database or any sources, then we select, like we select some target date, and then we select the data, then we pre-process the data, we take some transformation, right? Then we do data mining, and then we interpret and evaluate the results, and then from interpretation and evaluation of the results or models or data mining activities, you extract knowledge, right? So that's just called KDD process. Simple. Okay. And how do you manage a data science project? There are a lot of project management approaches. There is one approach that I personally prefer is Six Sigma. Okay, Six Sigma, what it talks about is first you define like the problem and objective. So there is one approach from Six Sigma like DMAIC: define, measure, analyze, improve, and control. So what do we do in define phase? In define phase, we define the problem and the objectives, like what problem we are going to solve, and what are the objectives of solving this case study, right? And then M is measure. So what do we do in measure phase? In measure phase, we check the current baseline, like where are we exactly? I mean, in terms of numerical, say ROI or whatever is current, say current efficiency, current number of resources, what are the challenges they're facing. So we measure the current baseline. And in analyze, like we analyze different factors, like what are causing the problems. Okay. From measure phase, we understand the baseline, and analyze phase, we understand the causes of the problem. Okay. And then once we understand the causes of the problem through statistical analysis or data science or machine learning, whatever, then we try to improve because we know like what are the causes of failure, right? So we try to improve those, and we try to fix those errors, those issues. And then finally is control. So once you improve, once you are able to improve, then obviously you need to sustain that improvement, right? So that's why control is important. So in control phase, assure that whatever you have achieved, that should not be reduced again. That's why you need to continuously monitor it, and you need to continuously improve it if required, right? Okay. And since I am talking about Six Sigma, what is one Sigma, what is two Sigma, what is three Sigma? Six Sigma is like one Sigma is like say 6,91,462 defects per million opportunities. Suppose you are manufacturing some of the products, like say some solar system products, right? In solar system products, one Sigma means like say in 1 million products, you'll get 1 million means 10 lakh products. You will get 6,91,462 defective products. Okay. In 2 Sigma, like 3,08,538 defects. In 3 Sigma, 66,807 defects per 10 lakhs product. Okay. So we are getting yield rate of 93.3%. We are getting success of like 93.3%. And so what is Six Sigma? This Six Sigma is like just 3.4 defects per 10 million opportunities. Think about it. It's rarely achievable. Okay. I mean, in manufacturing sector, uh, not rarely achievable. I mean, this is the thing that we need to achieve. 3.4 defects only per 10 million, I mean, 1 million opportunities. So yield rate is 99.99966%. Right. So basically, what Six Sigma is nothing but a complete process to improve your, to improve your process. I mean, a complete systematic approach to improve your current process. right? Now I'll talk about the different skill sets that are required to be a data scientist, or I would say, if you become data scientist, please have these skill sets. One is domain knowledge. I explained this already. Domain knowledge, like say you are working in telecom, so telecom knowledge. You are working in banking, banking knowledge. You are working in insurance, insurance knowledge, etc. And business knowledge. Business knowledge is different from domain knowledge. Business knowledge is like you may have different business units or departments. For them, you are going to solve a problem, right? So obviously, you need to understand their business, okay? Their current problem, challenges, what is the business they're into, right? And then statistics, obviously, is you need statistics. I mean, bit of understanding in statistics, machine learning, mathematics and algebra is needed. Programming obviously is needed. Software engineering, logical skills, data intuition. Data intuition means you must be at least, I mean, you should have some knowledge and intuition to understand what is data, how can we infer from this data, what are the things that we need to do, etc. And data wrangling, like you need to be hands on. You need to be able, I mean, you should be able to wrangle data, manipulate different variables, create derived variables. Okay. And then data visualization, I already talked about it, why it is important. And finally, communication. So let's highlight this communication piece. Unless until you are able to communicate properly, whatever skill sets you have, whatever, I mean, suppose you are the best in data science, you are the best in statistics, you are best in mathematics, you are best in software engineering, you are best in programming. But unless until you can communicate properly, then all of the skill sets go in vain, right? So it's important that you communicate well, you present well, and you depict well, right? So communication is pretty important. Communication reporting skills are important. So never overlook, I mean, this communication piece. So that's all the right skill sets to become a data scientist. Or if you become a data scientist, please follow this. That will be good. And if I talk about an ideal data science team, this is the ideal data science team. Okay, because data science is not only about algorithm. You know how I define data science or software development? I define data science and software development process. Same. How? Now let me explain you. Software development project also starts with kickoff meeting from business stake or business owners or stakeholders. Data science project also starts with the same activity. And in software development also we gather requirements. In data machine learning also we gather requirements. In software development we also draw architecture. In machine learning also we draw architecture. In software development we have some of the well planned activities. In machine learning also some we have some well planned activities. But the difference is in software development we have predefined uh, some logics or features which we need to develop, which you need to come up, like say some of the website features, some website designs, some of the logic, some of the preset rules, etc. And there machine learning differs. Machine learning is not a set of predefined logic, is not a set of predefined rules, but it is more to do with a statistical approach and probabilistic approach. So when we are talking about probabilistic approach, it is not a static anymore. It is dynamic and it is varying. It varies actually. Suppose I am building a model for a problem statement. Same problem statement say could be loan defaulter prediction, and XYZ someone else is going to build the model. My model and his or her model will be different. Okay, it's not static one. It's not constant one. And there in that piece machine learning differs from, yeah, I'll talk about you what is the difference between data analyst, data scientist, and data engineer, right? Okay, I'll talk about it. So that in that piece machine learning differs from software development life cycle. And after that piece again same approach like software development, you check code quality, you check DevOps, development operations is nothing but like collaborating between multiple teams, checking code quality, checking code standard, okay, making it scalable, distributed, etc. That's what we do in DevOps. And after DevOps we adopt monitoring, like once we come up with application, um, we check whether the application is working well or not, right? And that's why monitoring comes into picture. And after monitoring we go for deployment, like once we are confident that our process is improved, our model is working well, so that time we go ahead with monitoring, and we check the quality of the application in an continuous basis, right? And then we improve and we keep controlling. That's how this thing. And what is ML resources? Like data analyst, okay, data scientist, data engineers, business analyst, programmers, domain experts, big data experts, cloud experts, visualization experts, and software developers. So what is the difference between first three? This is important. You need to understand that. So data analysts are like initial stage, career stage for data scientists. So data analysts, what they do is they have good understanding about data. They have good understanding about statistics. They have good understanding about exploratory data analysis, but they may not be good in data science or machine learning as overall. Okay, so data analysis is the pre-stage, first stage of being a data scientist, where you help the data scientists and data engineers, okay, to say analyze some of the data statistically or the basic data analysis, exploratory data analysis, and then you pass to data scientist. Data scientist will are more experienced, right? More in terms of expertise level, they are more expert, and they know the overall process, so they can adapt any specific technique, model, etc., and they can fine tune. They can make your process better. And how data engineers are different? Data engineers, like they do mostly data related activities, like say some data are stored in big data like Hadoop data lake. Okay, some data are stored in SQL database. Some data are stored in say PostgreSQL database, Oracle database, etc., Teradata. So they help us to fetch to get data. They help data scientists and analysts to come up with the required data sets from different sources. That's the activity for data engineers. And also like create data lakes, maintain data lakes. Okay, so those are the activities for data engineers primarily. And business analysts, they help these people, data analysts and data scientists, with some analysis coming from say business stakeholders. Like they, based on the kickoff meetings, they will note down different activities, different conversation, okay, different topics, and they will uh, present in suitable manner, which is helpful for the data scientist to understand the entire business. That's what the primary job of the business analysts. Okay, and programmers, you obviously know, like who programs, who codes. Domain experts, I told you, like someone must be there who is very good in telecom. If you're working in telecom project, someone must be there who is very good in banking if you're working in banking project, right? Those things. Big data experts, like who are expert in big data only, right? They can help you once you need to adopt data science or analytics for big data. They can help you. Cloud experts, like who are expert in Azure, Google Cloud, AWS, and they can help you to deploy machine learning models in cloud. Visualization experts, being a data analyst and data scientist, you yourself can be a good visualization expert, but sometimes depending on the project specific need, suppose it's not a data science project but it's a more on reporting and BI project, right? um, then we need some visualization experts also. And software developers, we need to make it a scalable product. Like they need to know, I call this as full stack engineers. Software developer or full stack engineers. So full stack engineers help us to create some APIs, to create some applications. It could be desktop application, it could be web application. It has front end and back end activity again, right? So accordingly, we'll have these resources and we'll be able to get a successful project, right? Now, what are the activities in the life of a day-to-day, in the day-to-day life of a data scientist? Okay, I have some question, I guess, from some candidate. In current scenarios, client also expect to have knowledge of ETL and data warehousing from data analyst or W developer. Yeah, good question. And it's a funny thing, like in the current stage, recruiters or any companies expect everything from a data scientist. Whatever I covered here, they expect all of this from a single data scientist, and that's rarely achievable. Trust me, that kind of resource do not exist. And if they exist, mostly I'll be saying that they are fake. I mean, see, no one can know all of these topics, right? Obviously, if I claim that, okay, I know all of this, no, I don't know all of this. Maybe I may be good in analysis, I may be good in data scientist, I may be good in as a business analyst, I may be good in some visualization, but I'm not good. I mean, I may be good in domain, but I'm not good in big data, data engineering, cloud, software development. No, I'm not good. So no one can be perfect, right? So though the recruiters are expecting, I know, I go through the JD. I am also recruit. I mean, I also recruit so many people because of my team, right? And trust me, when I'm reviewing CVs, I give less importance to. I mean, I give importance like who knows all the things, but it's rarely achievable, and it's not a good expectation. It's not a realistic expectation, I would say. The recruiters must understand that a single resource, uh, they may not be knowing all this, right? So don't be afraid, whoever asked this question, or in fact all the attendees, don't be afraid, please. Go one by one. I'll suggest you go one by one. uh, and then to answer you like, then can I not be a full stack engineer? No, no, yes, I am saying you can be a full stack engineer, but go slow, go in phases. First learn analysis, then data science. You need to learn some of the big data topics also, data engineering activities also, and slowly once you start working, you will be a good business analyst also based on your expertise, right? And if you know some of the programming languages pretty well, you can, obviously you are a programmer. Domain expert, once your experience grows, you can be a domain expert. Big data, you need to learn it slowly. Cloud, you need to learn it slowly. Visualization, obviously you will be knowing from statistics, right? And then can you be a software developer? Yes, you can be a software developer. Slowly you go to that phase once you understand this, right? So that's how, um, I would suggest. So good. Now let's see what are the day-to-day activities. Like it starts from business understanding, and what are the things that we do in business understanding? Like we set objectives, we plan the project, we define the success criteria for business, we define the success criteria for ML, right? We analyze the cost and benefits that we are going to arrive out of this project. Okay. Data understanding, explore data sources, data definition, verify data completeness. It is important, like you need to have complete data set, which you need for your analysis. So if it is incomplete, please get it completed, and collected and then completed. Check data quality. This is very important. Like data quality, if it is poor, then your machine learning model may not work well. So you need to have good quality data. And sometimes you may need external data also, like say some of the macroeconomic and microeconomic factors, like say unemployment rate, GDP, interest rate, weather events, occasions, rainfalls, etc. So you may need those external factors also for some of your projects. That time external data sources are required. And what do you do after data understanding? Data preparation, like select scope data, clean data, construct required data, integrate data, and final analysis data. Okay. And once you prepare data, you go for modeling. In modeling, what are the activities? Select modeling technique, like which model you are going to adopt, generate test design, test cases, build model, assess model, finalize model. Okay. In evaluation, you evaluate the results, which is coming from multiple models. You optimize the model, like if some of the models are not working as expected, you optimize that, fine tune that, and then review that process, right? If it works well, then go for deployment. Plan for deployment, choose the right cloud, plan for monitoring maintenance. You prepare final report presentation, which is coming out of a complete application, and present to, review the project and then present to management or stakeholders, and then go for continuous improvements. So these are all the activities that we perform in our day-to-day life. Got it, right? Now, again, I'm going to repeat this slide, but in a different context. Like, what is the life cycle? Life cycle I already explained to you, but just quickly: business understanding, then project-related matter, then data analysis, then machine learning, then continuous delivery and continuous integration. Right. So, in business understanding, we do shareholder interaction, day-to-day process. We understand the day-to-day process. We generate many validate ideas and then validate those ideas, like which is best ML project, and then we finalize that idea. Set objectives, business impact, and then success criteria. Project related, like choose the project, clearly define the problem statement and the scope, right? Architecture and the proposed solution. Stakeholders approval is important, and then team selection, right? Once you complete this phase, you go for data analysis, initial data analysis, like data sources, data completeness, data quality, data collection and manipulation, preliminary analysis and visualization, and initial reports before going to the second phase, which is the automation phase, or say complete machine learning phase. Okay. In machine learning phase, like you do data wrangling, feature selection and transformation, uh, Do not be afraid because of these terminologies. I'll talk about it. Model selection, model validation, prediction outputs, presentation, deployment, final deployment. And continuous delivery, continuous integration is like reusable components you are going to come up. You are going to create different APIs. Suppose, what is API? Like we create some of the functions. API is nothing but like reusable functions you can think of. Okay, suppose you are developing a solution, and that solution you are going to sell to many departments. So what you need to do is you need to come up with reusable components in the form of APIs. So those APIs the client will be calling. So they may not need to know Python programming. They may not need to know R programming. They may not need to know SAS programming, etc. But API, they can integrate directly in Java, or say some of the front end like Angular JS or React JS and so on. So they can use your API and they can integrate in their application. Okay, that's how reusable components you are coming up with. And then DevOps and MLOps, distributed and scalable. You need to make your application distributed, make your model distributed and scalable, so that suppose when lakhs of customers are hitting your application at the same time, it should not be down, right? So it should be distributed and scalable also. Like scalable, why scalable? Like it should be scalable for huge data set, or say unknown data sets, uh, or or it should be able to handle large data sets, right? Monitoring and maintenance, you need to monitor your application and maintain it. Cloud, continuous improvement. That's an ongoing process. You will do it based on your feedback mechanism loop, how it is working. Do you need to fine tune your models after say 6 months or 1 year? Those things. That's the entire life cycle of a machine learning project. Sorry. Now let's talk about different use cases. Here I am not, obviously this is not an exhaustive list, but I tried to cover some of the important projects so that all of you from different whatever background you are from, you understand where we apply machine learning. Customer segmentation, like say banking customer segmentation, telecom customer segmentation, etc. Customer risk profiling, like say if I am having so many customers, what is the risk? I mean, what is the risk of losing customers, etc. So you generate some risk scores, okay, and based on those risk scores, you define the credit rating, okay. And fraud detection, like which customer will do fraud, etc. Which customer will do loan default. This is important. Personalized marketing. If you remember earlier days, decades back, marketing was like word of mouth or some leaflet handling, etc. Right? Distribution of leaflets and so on. That time, digital era was not that much there. So currently, the marketing is pretty different from the earlier ones. Now we have Facebook marketing, Google marketing, Microsoft marketing, and this marketing also use machine learning in the backend. How? Like let me give you one example. Suppose my purchasing behavior could be different from XYZ's purchasing behavior. Okay, our preference and XYZ's preference can differ, right? So those things can be understood using machine learning. Okay, and using machine learning, once we understand the preferences, the personalities of different individuals, then we customize our marketing plan accordingly. Suppose I'll send um, maybe some say data science related books advertisements to say XYZ or Abhinash or Adhikari or whatever, and say I'll be advertising sports related materials or products to somebody who is in the industry, right? Similarly, just to give a real life example. And then recommendation engine, it also use machine learning, like how we get recommendation from eBay, how we get recommendation from Snapdeal, how we get recommendation from Flipkart, Amazon, etc. That also uses machine learning. Cross-selling, upselling. Cross-selling, upselling is like cross-selling. What is cross-selling? Like say uh, along with bread you are also selling milk, right? It's a good combination, right? That is cross-selling. And what is upselling? Upselling is, let's say somebody is regularly purchasing some of the product which may be of smaller size, and sometimes he is also purchasing bigger size. So you can, what you need to do is you can upgrade the customer, like okay, we are giving this in terms of 500 gram, this is the price, so 1 kg, this is the reduced price, so take the 1 kg, and you reduce this discounted, I mean you pay us discounted price, right? So customer will be interested to purchase 1 kg product instead of 500 gram product. So that's called upselling. Okay. And pricing and promotions like product pricing, promotion, this is also needs machine learning. How do we define the pricing of a particular product? How do we promote the product? So demand forecasting, like how demand will be generated in future, what will be demand of this particular product in future, right? Accordingly, maintain the stock, etc. Stock market prediction, this is a very good example of using machine learning. Stock market is being predicted using machine learning, artificial intelligence, forecasting, right? News classification. So suppose we have some news, we want to classify whether it is based on sports, whether based on some politics, whether it is based on some like entertainment or say Hollywood industry or Hollywood industry, whatever, right? We can do news classification. Product subscription, like whether my customer will subscribe to my product one or product two, etc. Transportation optimization, like for Uber and Ola, which is the best way to save cost, to save fuel, right? To overcome the traffic, right? I mean, those things. Search engine optimization, like Google also use machine learning. When you are searching, like say, I want to know the names of like actors who were born in the same year as of Amitabh Bachchan, right? Something like that, or say, what are the best books in data science? Those things like so. Search engine also uses machine learning, and it gives the relevant answers only, not the invalid answers. Email analysis. Sorry, this is spelling mistake. Email analysis, like you have a lot of emails, you want to understand the context, summarize the content of the emails, you can do it using machine learning. Automated claim settlement. Suppose you have claims in banks or insurance, right? Insurance companies also may adopt machine learning to settle the claims automatically, because it may have some of the filled up forms, and they can say used image mining and text mining to extract data from those filled up forms, and then they have your contact number, they have your bank account detail directly using those forms, from the forms using machine learning, and they can initiate the claim settlements. AI powered chatbots, like bank, insurance, many companies, they adopt chatbots in their website. Those chatbots are not intelligent, but we can make it intelligent using AI. That's a good example. Smart assistants like say Google, Amazon Echo, Google Speaker, those things, right? Robotic process automation. This is important, like how you automate a process. This is directly not related to AIML, but you can use AIML also. Okay. Cyber security, like there are security issues in digital industry, so you can check those cyber security in advance, right? And you can adopt corrective measures. Document classification, speech recognition. Okay, speech recognition, like somebody sometimes say like five people are talking, speaking with each other, and we want to know like which speaker, who is the speaker one, speaker two, speaker three, etc. So we can do it using machine learning. We can do image recognition and classification, like we can understand whether it is a cat image or rat image, whatever, or say this person is different, this person is fair or not. Those things we can do using image recognition and classification. Video analytics, like we can understand the expressions of a so interviewee, we know like whether it's good or bad, what his expression is, those things. Social media analytics, like Facebook uses a lot of analytics and ML for their contents, such as like to recommend the friends, right, to connect with, to recommend the books to like, to recommend some of the movies to like, etc. Right? Emotion recognition, as I already mentioned, like from some of the image, some of the videos, we can detect emotion of some of the people. Drug discovery, this is very important. This is used in pharma and healthcare, like COVID drugs. This go through a lot of analysis, a lot of machine learning, okay, before it comes to market. Copyright identification, suppose you are suppose we are copying some of the contents, we can detect whether it has copyright issue or not, okay, using machine learning. Fake news detection, smartphone user behavior analysis. Anomaly detection is nothing but like say rare value detection. What is rare value detection? Suppose you are using your laptop or desktop, right? So rarely it will fail someday, right? So depending on the condition, I mean, you may gather data from your system, and we can adopt machine learning to analyze that features. It could be your number of applications installed, number of software installed, your hard disk, your RAM, your processor speed, some load balancing, right? Load capability, those things we can detect whether at a particular day or time your system will fail or not, right? Automated information extraction, like say I mentioned already, there could be many financial reports or say insurance reports or say legal reports where we may need to extract information, necessary information that you can do using text mining, NLP, etc. So these are few of the interesting use cases. I hope this will give you a good glimpse of machine learning where and what are the industries that it is being used. If I talk about industries, it is applied everywhere. It is applied in government, it is applied in education, it is applied in policy making policies, it is applied in sports, it is applied in utility, it is applied in energy sector, it is applied in say solar systems, and it is applied everywhere. Machine learning is applied everywhere. Okay, you can't imagine like machine learning, how machine learning can help multiple business units and service units on different domains. Having said that, having said like so many applications, there are many challenges also. What are the challenges? Okay, actually, let me talk about the challenges. So if you have unclear problem statement, if you are coming up with the unclear problem statement, then you are going to get a failed machine learning project. Trust me. So problem statement must be very lucid, very clear, and to the point. Okay, then only you will be able to solve it. Lack of domain knowledge. This could be dangerous also sometimes. Okay, this can also cause a machine learning project failure. Identifying correct data sources. Suppose you have a lot of data sources, but we do not know like which data sources are important for my machine learning project. That time also the project will fail. Data unavailability. This is one important issue. Like sometimes what we have observed is a client want to solve machine learning using machine learning, but they do not have the data, necessary data. Okay, so data unavailability. And sometimes even if the data is available, it is not complete. So we need to check the completeness of the data. Sometimes if we have available data, if any of it is complete, the data quality is poor. So you need to check the quality of the data. Not having a purpose. This is the case with maximum many organizations these days. Like they do not have a purpose, but they forcefully apply machine learning. Okay, do not fall in this category. You learn it properly and then apply it. Okay, not having a proper plan. So as I said, like many companies want to adopt machine learning, but they do not have a proper plan. That's a dangerous thing also. Okay, wrong expectations. Wrong expectation could be from your manager. Wrong expectation could be from your management. Wrong expectation could be from your recruiter. Wrong expectation could be from yourself itself. I mean your say confidence. You are confident about solving a problem, but you are thinking that okay, I can generate 100% ROI. That's not possible. You can expect say 15% ROI, 20% ROI, maximum 30%, 40%, but not 100% or not 300%, etc. So make your expectations realistic. No prioritization. Suppose if we are unable to prioritize, suppose we have 60 to 70 ideas to solve. If you are not prioritizing, then it's not good. So we need to prioritize it. Not a structured team. I have seen in many companies like they adopt machine learning, but then there is not a structured team. That is also a challenge. Okay, trying to dive into machine learning as a first step. So many companies want to adopt machine learning as the first step. That is good and important, but initially it will have some challenges, right? It's not a bad thing. Every company, whoever is going to adopt machine learning as the first step, obviously challenge will be there. So here I'm just mentioning the challenges, right? And one more challenge is waiting on perfection, artificial requirements. This is important. Like no one of us can be perfect. Our machine learning project is obviously not a perfect one because, as I said, it's a probabilistic model. So it will be having some errors, random errors, etc. So you need to accept that. Okay. And unrealistic metrics or KPIs. Just I mentioned, like say, we can't expect say 1,000% ROI or say 300% ROI. So the metrics, like say, what is the efficiency gain, how many resources you can save from the project or from the automation, those things must be realistic. Demanding instant results. Some of the people will demand from you like instant result. Okay, I've given you this problem today, so solve it tomorrow. Machine learning project does not work like that. Okay, it needs a lot of R&D, it needs a lot of data wrangling, it needs a lot of activities, visualization, pattern mining, etc. So obviously we can't give you instant results. Competitive mindset. Sometimes this is a dangerous thing because in companies I have seen there are too many data science teams and they are competing with each other. That's not good for any organization. Okay? You need to have a, I mean, though you may have several data science teams, but please bring positiveness and collaboration. Okay. No collaboration and sharing. Sometimes people do not share things with each other, so these things should be taken care of. This is one of the challenge. Improper execution and management. Suppose everything is taken care, but the management is not executing it properly, or the project manager is not executing it properly. That is also a challenge. And finally, improper team selection. Suppose you want to solve a machine learning project, and you are taking some, say, resources from some other background, or I mean absolutely from other background, and they suppose they are not confident about machine learning, they do not know, right, those things. So choose team wisely, choose the best resources, and who can be beneficial for the team and who can work rigorously, right, being passionate, being dedicated, being honest. And that's more important, I mean, that's according to me. So that's all for the day.